What's going on, everyone? This is going to be a very long video. It's going to be full of information, and yeah, get your notepads out, get ready to learn. So I'm going to use this session to talk you through a project that I'm working on and that I've been working on for the last few months for a client. So at the moment, one of my clients are a EV charging company. So this video, I'm going to cover the architecture, what they've done in terms of AWS, and what I'm doing to help them build something better. So they're an EV charging company. Think of them as a Tesla, and you know, Tesla chargers, the ones that you put in at your house or in like offices. That's what they do. They just create those chargers that you put your electric car in. And that charger is connected to AWS. It also has a mobile app that's also connected to AWS, and it sends and receives data about charging and all that shebang. Anyway, what they've done is they've built their environment in AWS Cloud. However, they built it all about 5 years ago using the console. So they basically built their whole business, right, from scratch using the console, using the AWS UI, clicking through the buttons, setting up databases, you know, the servers, storage, networking, all via clicking via the console. This is a very bad practice because if, God forbid, someone hacks into their network and then to their application and into their AWS account, they could delete everything. Of course, it's not that easy because there'll be security around it. But just imagine they go into their account and they delete everything. It will take so long to go back and recreate all those configurations again. And that's why you need to start using infrastructure as code as soon as possible, because you can build their infrastructure or any application and any business infrastructure with code, which means it's repeatable. You can reuse it. If something goes wrong, something goes down, someone hacks, deletes everything, within 5 minutes, you can get that exact infrastructure back up and running. Anyway, that's a side note, but let me show you what their architecture looks like. So they just have a single VPC, and we'll put that in green. And inside the VPC, they've got 2 availability zones, like this. Let's go blue, and let's go dotted. So these are the availability zones. Inside those availability zones, they have a single subnet. And for those who've watched my networking video, you'll know that having a single subnet is not AWS best practice. This is a public subnet as well, which is not what you really want. And it's the same over here. That inside their public subnet, they've got a host of AWS services. So they've got their main application running on Beanstalk. Doesn't look like they have it. So just imagine we've got EC2 here. Just imagine this is Beanstalk. Bring it forward. Yeah, just imagine this is AWS Beanstalk. Oops. Okay, it's not working. Beanstalk. If I can spell properly, guys. Okay. So the good thing of this session is, I know it's going to be long, but you're going to see how I put together architectures, and you'll be able to see the patterns that I use and how I just pull quickly a diagram together. So they've got Beanstalk, they've got S3, like this. They've got a DynamoDB. A DynamoDB doesn't actually sit inside the subnets or inside the VPC because it's like a regional service, so it actually sits outside the VPC itself. This is so flimsy. Anyway, it's all fun and games until you start using icons and they just mess you around. Anyway, it sits outside the VPC. So let's move that across. Actually, the S3 is also the same, so this will sit here too. Anyway, and then they've got Elastic Cache. It's like a caching database. Redis. That could be other name. Anyway, it's got a database as well, and that's being used for caching. Cool. So just imagine they've got all the infrastructure. It's in a subnet. They've got these connections, and yeah. So the issue they've got is essentially what my role is. They want me to come in, or I've been in this company now for a few months, helping them move away from this environment into a brand new AWS best practice environment. So this actually is in London, in the London region. And what I'm doing is I'm doing a complete infrastructure migration. So what that means is I'm building them a new AWS account and a new AWS environment using infrastructure as code with CDK and TypeScript. And what I'm doing is I'm following the AWS best practices, as everyone should. So let's just delete these. So I've come in. Where's the networking diagram that we had earlier that I used? Dun, dun, dun. Okay, yeah. So let's just copy this over just because it's easier and will speed things up for us. Let's move back. So I'm coming in and I'm creating this setup. Let's delete this. This setup. So we're splitting up the subnets. Of course, what you don't want is have your application and your database running in the same subnet. That's not the best practice, the way of doing it. You want things isolated. You want things separated. So there is no interaction or any sort of corruption or anything like falling and breaking and not working. So what you want to do is you want to keep your services separate in different subnets. So you want your application to be separate than your database, separate to the NAT gateway, and so on. But obviously they don't have that at the moment. So what I've done is I've come in, I've built this whole environment. You can see the networking, the subnets, EC2, the NAT gateway, the internet gateway, all using infrastructure as code. And what we're doing is instead of doing a full migration, we're doing more of an iterative approach to a migration. And we're moving over the server first. So we've moved over this Beanstalk application first, and that's now running in this new account. This is actually in the Ireland region, EU West 1. Remember, these are just naming conventions. So what we've got now is we've got a dual running of our infrastructure. So what we need to do is, obviously, we've got our application running on EC2, now in Ireland, but the backend, i.e. the data layer, is still running in this old AWS account. So what's happening is connections are coming in to this EC2 or this application server in London, and then that's routing the request through here, basically through to London. And what that connection looks like is actually through a VPC peering connection. And a peering connection, sorry, that was wrong. It's actually going through the peering connection, that reminds me. A peering connection is basically allows you to connect two VPCs together on the AWS private network. So the requests are coming in from the internet or the users to this server running in Ireland in our public subnet. Obviously, it's going through the internet gateway, right? And then it's going here. So let me just update that correctly for you guys. And there's a load balancer in between, but we won't go to that detail. And then what's happening is the database and the backend is still connected in London. So what we're doing then is we're serving the request through the peering connection, which connects two VPCs together, to our data layer. So any requests will go over the peering connection and keep the connection secure and away from the public internet. This is a real project example that you guys could be working on. This is an AWS migration from a console manual configuration to an infrastructure as code environment, but also following AWS best practices from a networking point of view, from a connection point of view, from a security point of view, from an infrastructure as code point of view. This is how it should have been built. As you can see, this is how AWS recommends that you build networking architectures inside your VPC, multiple subnets, isolated, all for individual purposes, whereas they just went a bit freestyle just to get something up and running, very much startup vibes, and they just got something up and running, but now they've realized that they need something better, more secure, that scales, that's also has got infrastructure as code. And that's what I've been building. I've basically got to a stage where I've built all this networking layer. I've built an EC2, like I said. I've built a peering connection. And now, actually, we have live customers coming through from this server to the peering and connecting to the back end, which is really, really cool. And in the Cloud Engineer course, I know so many of you guys watching this are already on the Cloud Engineer course. We're going to actually use this as a real example to go and build ourselves in the Cloud Engineer Academy, as it's been renamed as of today. And that's going to be really cool because you'll be learning and building and creating a real world project, a real world problem that you can then use as leverage in your portfolio. So it'll be something like, let me give you an example. You've got a customer who's built their infrastructure using the console in AWS. They now want to follow AWS best practices and build an infrastructure as code environment. And then obviously the project will say, we want a networking layer, we want VPCs, we want to connect things up together, we want to keep things secure, and then we'll go and actually build it. So super, super exciting. And yeah, that was a quick overview of a real world project, a real world problem that I'm actually working on for a client. So remember, they built something using the console, which is in best practice. I've come in to build them a brand new AWS world with infrastructure as code, but then also helping them with the migration of their services. So after we've moved over this connection, this is all working. From January, we're going to start focusing on the databases and the data layer. So the next thing that we'll migrate will be this Elastic Cache Redis into this private subnet in London. So what then's going to happen is any connection that wants to read the cache will just connect this straight to the subnet here. We'll set up the security groups to allow inbound connections, and we'll set up the routing in the route tables to allow the communication, and then we'll still serve any connections to the S3 and Amazon DB, Amazon DynamoDB through the peering connection. And then obviously once this Redis is done, then we're going to move over DynamoDB, and then we're going to move over S3, and eventually this whole AWS console-driven environment will be removed and deleted from the face of the earth. Hopefully that was a good insight into what you guys could actually be working on a client project. That's exactly what I'm working on right now.